let's start with one question which was asked in 2024. So here a beam is given PQ and 3 kilonewton load is applied on it. There is some spring over here. Okay, so distance from P is 1 meter and this is 2 meter. Okay, so Kp is the stiffness of this P and Kq is the stiffness of this portion Q. Okay, so this is your P and this is your Q. Now they have told us this is 3 meter long horizontal rigid uniform beam. So horizontal, they have told us that PQ is basically horizontal rigid. So each and every term we have to understand that it is horizontal, it is rigid. Rigid means it will have no deflection of its own, either it will remain straight. Okay, even though load is coming, it will directly go down, okay, by same proportion. Okay, it will not deflect like this, it will not bend. Okay, so it is rigid. Uniform beam PQ has a negligible mass, so its own self weight is 0. Okay, so negligible mass. The beam is subjected to a 3 kilonewton concentrated vertically downward force at 1 meter from P. We have seen the figure. Okay, the beam is resting on vertical linear springs at the ends P and Q. For the spring at the end P, the spring constant, okay, that means stiffness Kp. Stiffness, we know what is stiffness. Stiffness is basically action upon displacement. Okay, action upon displacement. So they have given us the spring constant. Either they can write it as a spring constant or stiffness, both are one and the same thing. Okay, now they have asked us to find out the value of Kq. They have asked to find the spring constant or stiffness of another spring. Okay, so let's draw free body diagram. So here I am drawing the free body diagram. You can see this is point P, this is Q. So there will be some upward reaction. This is load 3 kilonewton. This is 1 meter. This is 2 meter. Now this is spring and here also some downward force will be acting on the spring. So this reaction, vertical reaction, let me write Vp and Vq. See, just by applying the equilibrium equations, sigma Fy is equal to 0. That means sum of vertical forces is equal to 0. Vp plus Vq is equal to 3 kilonewton. Now moment at P is equal to 0. So let's take all these forces, 3 into 1 clockwise direction plus minus 3 into Vq. This is anti-clockwise is equal to 0. Therefore 3 Vq is equal to 3. So Vq will be 1 kilonewton. So Vp will be 3 minus 1, that is 2 kilonewton. So Vp is equal to 2 kilonewton, right? So this 2 kilonewton will be acting in downward direction on this spring, and here Vq is equal to 1 kilonewton. So here 1 kilonewton will be acting in downward direction. So again there will be reaction over here. Okay, now individually we will see. Suppose for this P spring, stiffness is equal to Kp, that is 100 kilonewton per meter, is equal to action upon displacement. So how much force is there? 2 kilonewton divided by displacement is deflection. Okay, so I don't know, so let's write delta P. Same way for stiffness of Q, that is Kq, action upon displacement. So this is action is 1 kilonewton upon delta Q. Okay, now we know that this bar is rigid bar. So delta P is equal to delta Q. Okay, so delta P is equal to delta Q. So 2 by 100 delta P is equal to 1 upon KQ. Can I write from the above two equations? This is equation 1, this is equation 2. So from this KQ will be 50 kilonewton per meter. Okay, so this is the final answer. Thank you very much.